Today, my task is to conduct a parameter and non-parametric tests for significant difference of two samples in datasets. So this is our assignment from Dr. Salva. So the first task is conduct an independent t-test to determine the answer of research question number 1. And the research question number 1 is there a significant difference in the mean IQ of 3-year-olds and 11 years olds? On the right side, you can see the data. So this data will be encoded to Microsoft Excel. Actually, I have already encoded it. So let us locate the Microsoft Excel. So here, so we will be conducting t-test. So I've named it as t-test, and this is the data. Now we're going to save it as CSV file in order for JASP to open it. So CSV delimited t-test. Okay, so since it's already saved, we will open JASP to create data or to create statistical outputs. So click on JASP and let us locate the t-test CSV file. Here is the t-test CSV file. Open. So here is our data. So see to it that the values here is on the top. If you're going to click that, it should be scale, and this one, since this is nominal, so it will be nominal. So now we will conduct the descriptives in order to data distribution. So is there a normal data distribution? So here we go to statistics and we will look at the mean, skewness, or check this one, kurtosis, Shapiro-Wilk. We can also add the QQ plots and also the box plots. Yeah. So as we can see that there are results. So if we're going to look at the p-value of Shapiro-Wilk, so we have here 0.836 and 0.521. So the p-value is higher than 0.05. This means that there is a normal distribution of data. And we can also see at the QQ plot there are more data that is attached to the 45-degree line. There. So now that since we have seen that the descriptives or the data is normally distributed, then we go to the t-tests. So click on t-tests, then click on independent samples. So click on this variable and then the grouping variables. Then we will use only student. So as you can see, our p-value and is 0.101. So if we put descriptives also, so we can see the mean and the standard deviation and the number of participants. So we have also here the coefficient of variations and the standard error. So with this result, we can interpret or give our decision. So since the p-value is greater than the alpha, which is 0.05, so we fail to reject the hypothesis. And the conclusion is that the probability value in the independent t-tests of the mean IQ of 3-year-olds and 11 years old is greater than 0.05. So this means that there is no significant difference in the mean value of IQ of 3 years old and 11 years old. And also for APA format, a t-test failed to reveal a statistically reliable difference in the mean of IQ scores of 3-year-olds where mean is equal to 117.636 and a standard deviation of 13.559, and for the 11-year-olds the mean is 127.833, and for the standard deviation of 14.801. And the DF means, this is the degree of freedom, which is 21, and this is equivalent to negative 1.718, and our p-value is 0.101 with alpha equal to 0.05. Our task number 2 is to conduct a Mann-Whitney tests to determine the answer of research question number 2. And the research question number 2 is there a significant difference in the average mean of objects recalled by participants in the sleep group and no sleep group? So here we can see at the right side the data for the sleep group and for the no sleep group. So first we are going to encode this, but actually I have already encoded it, so I will just gonna open it. So this is the Whitney test, so this is the data, and now we're going to save it as CSV file. So click on that, save as, then CSV file comma delimited. Then we save it as Whitney we save it as Whitney test. Then we open JASP to treat the data. Okay, so we use the Whitney test data. Okay, so now we will conduct the Mann-Whitney tests with the use of JASP software. So to do that, we have to click on the descriptive first in order to see the normal distributions. So first we go to this, the variables, and then the groupings. Then let us see the statistics, skewness, kurtosis, Shapiro-Wilk. Okay. So as you can see, the p-value of Shapiro-Wilk is 0.471 and 0.803 for number 2, which means that this data is normally distributed. Since it is normally distributed, then we go to the independent t-tests, and this time we will use Mann-Whitney tests. So we transfer this in the dependent variables and the grouping. So as we can see that we can add also descriptives. Okay. So as we can see that the p-value of the Mann-Whitney test is equivalent to 0.076, which compared to the alpha, which is the 0.05, it is greater than the alpha. So by this information, or by this data, or this result of the independent t-tests, we can say that we can interpret or decide that if p-value is greater than 0.05, then uh, we fail to reject the hypothesis. And the conclusion is the probability value in the Mann-Whitney U-test mean of objects recalled by the participants in the sleep group and the no sleep group is greater than 0.05. Therefore, there is no significant difference between the mean of objects recalled by the participants in the sleep group and on the no sleep group. On the APA format, this is how we write it. So, a Mann-Whitney test indicated that participants in the sleep group has no significant difference where median is equivalent to 11, with no sleep group median is equivalent to 9, where the U is equivalent to 20 and the p-value is equivalent to 0.07. Our third task is to conduct a paired t-test to determine the answer of research question number 3. And the research question number 3 is there a significant difference in the mean of amount of material learned between the new method of instruction and the standard instruction? So here at the right side, we have the data and we will encode it again to Microsoft Excel. So we will be using the paired t-test this time, and we'll open this one. So I've already encoded it actually, and now we're going to save it as CSV file. So CSV, delimited. Okay. Now we use JASP to analyze the data. So let's open JASP. Then open the file. So we will use the paired t-test. Okay, so this is the data. Now, let us look at some descriptive first so that we can see if this data is normally distributed. So as we can see, the descriptive statistics like the p-value is 0.238 for the new method and 0.064 for the standard instruction. There. So which means that there is a normal distribution of the data. Now we proceed to t-tests. So we go to t-tests and paired t-tests. Actually, what we're going to do is the paired t-tests, but still it is on the t-tests menu. So click on that, then click on the variables. Okay, so we're going to compare the standard with the new method. There. So we see we use only student first. Then we see the we add descriptives the bottom. Okay. So we see that the p-value is equivalent to 0.084. So we can decide that the p-value is greater than the alpha, which is 0.05, which means that we failed to reject the null hypothesis. So the conclusion is that the probability value in the paired t-test mean of amount of material learned between the new method instruction and standard instruction is greater than 0.05. Therefore, there is no significant difference between the mean of paired t-tests, mean amount of materials learned between the new method of instruction and the standard instruction. For EPA format, it is written like this. So a two-tailed paired sample tests revealed that the amount of material learned between the new method of instruction with mean equivalent to 81.75 and standard deviation of 7.677 for the new method has no significant difference compared to the standard instruction with mean 78.65 and standard deviation of 7.625 with the t value 19, which is negative 826, and the alpha is equivalent to 0.05. Our fourth task is to conduct a Wilcoxon signed rank test to determine the answer of research question number 4. And the research question number 4 is there a significant difference in the water intake before and after injection of hormone Y? So the data is here. Again, we will be encoding this, or actually I have encoded this to Microsoft Excel already. So we'll just gonna open it. So we have here the Wilcoxon signed rank test data. So it's already encoded. So we'll just gonna save it as CSV file again, so that Jeff can open it. There, then save it as Wilcoxon rank test. Okay, so since it's already saved, we will open JASP to treat the data. So we will open the Wilcoxon rank test data. Okay, so here is our data. Now we will use t-tests for paired sample t-test, and instead of selecting student, we will use Wilcoxon signed rank. So we will add first the variables there, then we uncheck the student and check the Wilcoxon sign, then we will have the descriptives. So as we can see here, the p-value of the paired sample t-test is less than 0.005. So here we can interpret or conclude that here we can interpret and decide that the p-value is less than the alpha, which is 0.05. We reject the null hypothesis. So our conclusion is that the probability value in the Wilcoxon signed rank test mean of water intake before and after injection of hormone Y is less than 0.05. So therefore, there is a significant difference between the Wilcoxon signed rank tests mean of water intake before and after the injection of hormone Y. For APA format, we have here a Wilcoxon signed rank test indicate that the median of water intake after injection of hormone Y were statistically significantly higher than the median of water intake before injection of hormone Y, where Z is equivalent to negative 3.361 and the p-value is equivalent to 0.001.